Section 4, Surface Features of the Moon. By the way, in the little picture in the upper right-hand corner, you notice the moon kind of wobbles as it goes through phases. That's actually called lunation, and that's due to the fact that it's an elliptical orbit, meaning the moon is slightly closer and slightly farther during the month. Anyway, when you look at the moon, the two most obvious things are that there are light areas and dark areas of the moon. The dark sort of splotches are called maria, which in Latin means seas, which is kind of appropriate, even though they were named hundreds of years ago when people thought they might be actual seas of water. They were seas. They were seas of lava billions of years ago. The original crust of the moon, the white area, are called the highlands. The highlands. Now, one of the questions I get is how often do craters form on the moon? Well, it all depends on the size of the crater. But when you think of really big craters that you're going to see in a backyard telescope, then you're talking about most of them being billions and billions of years old. Back when the solar system was very young, there was a period called the early and late bombardment, two periods really, but where all heck was breaking loose in the solar system and everything was smashing into everything else. And when you see heavily cratered surfaces on moons or planets, it usually dates to that time. Having said that, yeah, there's still rocks flying around out there today. And so there are still impacts, but percentage-wise, most of them date to long, long ago. And of course, little bitty asteroids, or little bitty craters, I should say, form all the time, as we'll see in just a few minutes. And they are, of course, when you see craters on the moon, they are from meteoroids, not from, let's say, volcanoes or something like that. One little vocabulary term here. The line between day and night, if you see that on a picture, is the terminator. So kind of an interesting vocab term in astronomy. Okay. Here's a picture where you see the highlands mostly up here in the upper left, and you see the smoother maria down below. The highlands formed first. That was the original crust of the moon. And then, but very early on, lava poured out on the moon, and the lower areas filled up with lava. And it's like re-asphalting a highway or something. So that's why they're smoother. Now, having said that, again, all the surface of the moon is ancient. The surface of the moon is ancient. It's just that the highlands are slightly more ancient than the maria. And the moon, just like everything else in the solar system, formed about 4.5 billion years ago. Now, we learned before in the last section that when the moon formed, it became, over time, tidally locked with the Earth. So the same face was towards us, and then there was a far side always away from us. And so now, as promised, you're going to see, perhaps for the first time in your life, the far side of the moon. Keeping in mind the far side gets just as much light as the near side. It's not the dark side, it's the far side. And there it is. The far side of the moon. Only a few people have actually ever seen it with their own eyes. The few Apollo missions that went around the back of the moon. Very heavily cratered. Not nearly as many maria on that side. And that's still actually kind of being debated as to why that is. And there's another picture of it, kind of stark. I think we've got the nicer looking side of the moon myself. I want to try this little video clip just to see if you can hear it or not. I'm not sure how that works, but we'll try it out here. And they talk a little bit about this.
68. We now have high resolution cameras imaging every square meter, even the far side. And here's the amazing surprise. You would think that the far side of the moon would look like the near side. But check out the two hemispheres. They're totally different. The near side has huge regions of ancient lava flows called maria, while the far side is almost entirely covered in crater impacts. Planetary geologists aren't sure, but it's possible that the Earth used to have two moons. Billions of years ago, the second, smaller moon crashed into the far side of the moon, covering up the darker maria regions. And just to clarify things with Pink Floyd's reference to the dark side of the moon, except for the occasional lunar eclipse, half of the moon is always in darkness and half is always illuminated. But that illuminated half changes as the moon orbits around us. just like half of the Earth is always in darkness and half of every other object in the solar system. There's no permanent dark side of the moon. The side facing towards the sun is lit up, and the side facing away is in shadows. There are, however, some spots on the moon which are in eternal darkness. There are craters at the north and south poles deep enough that the light from the sun never illuminates their floors. In these places, it's possible that there are reserves of ice that future space colonies could use for their supplies of water, air, and even rocket fuel.
So that was a huge discovery, what he's talking about there, about discovering ice in the craters. That was back in the late 90s. And it really changed. We had kind of had no interest in the moon for about 25 years or so. And then suddenly it really changed when you realize that the number one thing that we need to survive is there waiting for us. So that's a big deal. Okay, we have a moon globe in my classroom. It's kind of fun to look at, and you see the names. And the seas have interesting names. Now, they were originally in Latin. So the most famous sea of all is where Neil and Buzz first stepped down on July 20th, 1969. Mare Tranquillitatis in Latin, or the Sea of Tranquility. And see, the moon can make you feel tranquil. So that's one of the seas. That's how they got these names. There's a Sea of Serenity, for example. And then other things they associate with the moon, like storms. So there's an ocean of storms. So they were just a variety of things that were associated with the moon. That's how the seas get their name. The mountain ranges, they got pretty lazy. The mountain ranges on the moon are simply named after mountain ranges on Earth, specifically European mountain ranges, the Alps, the Caucasus, Apennine Mountains, and so forth. And then finally, the craters, and this is kind of fun. Most of the people we talked about in Chapter 2 in the history chapter, they have their own craters, everybody from Newton to Einstein. But the ones that I would point out, Tycho crater is very prominent. It's in the southern highlands, and it really stands out. I mean, I think you can probably see it with your eyes if you have good eyesight. Tycho crater, Copernicus crater is another big one that's pretty easy to find if you like studying the moon. And there you can see in red, actually. See, there's you take kind of a sliding board down here. I don't know if you can see my cursor or not, but you kind of slide down the Apennine Mountains, and it goes right towards Copernicus crater. So that's easy to find. If you continue on, you get to Kepler crater. And then down in the south there, you see in red, the Tycho crater really stands out. It's actually younger. It's relatively young. It's like 100 million years old or something, but it's relatively young compared to most craters. You also see the seas, Mare Tranquillitatis, that I mentioned. And there's Apollo 11, sure enough, right there in the Sea of Tranquility. There was kind of an interesting battle, argument between the scientists of NASA and the engineers. What's the difference? Well, the scientists, when we landed on the moon, they wanted to go to interesting places with lots of different formations and craters and mountains and things. And the engineers said, oh, no way. We're not going to try to land. It's difficult enough to fly to the moon. We're going to land someplace really safe. So if you look at the first three landings, 11, 12, and 14, they're in relatively smooth areas. Of course, they wanted to land in safe places. And then we started getting, bolder as we got used to going there. And so the last few, I find the last missions actually much more interesting. A lot of interesting pictures and videos from them. The moon, of course, has no atmosphere, meaning that all the time it gets pelted by tiny little pieces of debris, little pieces of sand flying through space. The area around a crater, just another vocab word, is the ejecta, or the ejecta blanket, it's sometimes called. That's the area around it. So Tycho has a huge ejecta blanket around it. And as I mentioned before, most super large craters are really, really ancient. Okay, just a little bit here. So if you ask the question, how often do craters form on the moon? Every minute. I mean, every minute somewhere on the moon, some little grain of sand hits it and forms a tiny little crater. But if you're talking about really big craters you can see, then that's incredibly rare. And that's a good thing. We don't want a lot of large meteoroids flying around our neighborhood. Okay, here's one of my favorite pictures of the moon ever taken. This was by JAXA, which is the Japanese Space Agency, and their ship Cayuga. It's very reminiscent of an old picture called Earthrise that we'll talk about later. Beautiful, beautiful picture. That's totally real. This is an area called the Bay of Rainbows, one of the smoothest areas that I've seen on the moon. And this is a great illustration of how astronomers can very simply look at a surface and say, hey, if there are a lot of craters, it's a very ancient surface. It goes back to that time billions of years ago. If it's very smooth, it means it's been resurfaced, so it's a younger surface. Great example would be Jupiter's moons, Callisto and Europa, right? They're in the same neighborhood. And yet Callisto is the most heavily cratered object in the solar system. Europa has practically no craters. In that case, it's because Europa is being resurfaced with water from underneath its icy crust. So that's kind of cool. But whether it's from water or from lava or anything else, we consider it to be a young surface for that reason. We'll get to that more later. Okay. Lunar dust is not like dust on Earth, or at least not what we normally think of as a dust. It's more kind of like talcum powder. Very, very fine grained. Okay, or if you've ever worked with concrete, that really thin dust you get on your hands, it's very similar to the dust on the moon. So they even have a special name for it, regolith. It was actually a danger in the first Apollo mission. I believe, if I remember right, the filters couldn't even pick up this dust. It was so fine, and which was a real danger to asphyxiate the astronauts because they got caked in it. They were just covered because everything on the moon is really, really dusty. The dust itself forms a type of erosion. Every time you have little pellets coming in, little micrometeoroids, it is a form of erosion, but incredibly slow. That picture in the upper right-hand corner, that boot print from Neil Armstrong, it's going to be there for millions of years. So not too long from now, your descendants, my descendants, they'll go to sort of parks like we have national parks. They'll go to parks like that on the moon and not only be able to see the equipment that was left, but actually see the footprints of Neil Armstrong and Buzz Aldrin and things like that. It's pretty neat to think about. Check out the motion of the astronaut here and how much dust he kicks up at different times. Look at the dust right here, as he kicks up. It's almost like snow. You'll also notice the astronauts started skipping across the moon. Some of them decided that was actually a more efficient way to get around than walking. The last few missions, they actually were able to cover a lot more ground thanks to this lunar buggy. We're going to see one of those on our trip to Kennedy Space Center in January. You can actually sit on a mock-up of one of those. And then down below, you get a great example of the kind of terrain where they started getting bolder about where they could land. And there's a giant crater on the right and a giant or a mountain on the left. And there's the rover right there. So interesting stuff. Here, of course, is where we first landed in the Sea of Tranquility. And you see how relatively smooth it is. I mean, they wanted to land in the easiest place possible for the first mission. All that stuff's still there. That piece of equipment, that's a seismograph for studying moonquakes, which they didn't find. But that's still there. And the bottom of the lander is still there, the Eagle lander. All right. What else do we have? So I already mentioned the ice that was found there in the late 90s, which really changed our thinking of the moon. And there's a debate going right now at NASA. Are we going back to the moon first or going to Mars first? There's good reasons either way. There seems to be absolutely no activity on the moon, no volcanic activity. On the very last mission, in the last waning minutes of the last mission, they found that soil at the bottom right of the screen. The only geologist to ever go to the moon, you hear him on the audio start exclaiming, "It's orange." And it was the only color they ever found on the moon. Everything was this overwhelming gray. And in the last minutes, he digs it up and they find this. And what it is basaltic material. It's like dried up lava. So that's kind of neat. Now, back when there was running lava, the lava formed tunnels and ditches called rills, lunar rills. I'll show you one right now. There's a Hadley rill. Okay, now that rill looks more like a ditch, like a dried up riverbed, but some of them formed caves. We actually have this on Earth in places like Hawaii. And so very recently in 2017, the Japanese again, they were able to use radar and realize that one of these underground rills is so huge. I don't know if you can see this on the screen there, but to the lower left, that's the inside of one of these caves.